Hello, everyone. Thank you for attending this workshop. My name is Germán Martinez. I work on developer relations at SAFE, and I'm here with my colleague, Dani Somoza. Hey, Dani, how are you?
Hey, hi everyone. My name is Danny. I work as Safe as a front-end developer. Yeah, right now I'm working on the SDK. Mhm.
Great. So, thank you very much for attending this workshop. This is the first one of a series of different workshops from all the sponsors that are participating in this hackathon. I will share my screen. Just 1 second. There we go. So the workshop from today is about the SafeCore SDK, an introduction to it uh, from the AI Agentathon workshop. So let's start. If you have heard of Safe, Safe is a smart account that allows to access the funds that are stored in the Safe smart contract with a private key or different private keys. Because one of the main features is that Safe is a multi-signature account, so you may have one or multiple of them. People usually have a couple of them and then set a threshold, let's say 2 out of 3, meaning that at least 2 of the private keys need to sign every transaction that is executed in order to make it executable. So you don't need to sign with all of them, but also one of them would not be enough. This is configurable. You can set up as many as you want. Usually people have, if they are using Safe for personal use, multiple devices with one private key on each device, or if multiple people are sharing the same Safe account, they are holding one private key each. With AI, this may be different. Maybe you don't want to hold a private key, but you want to give the private key to an agent that has full control and decision of all the actions and transactions that are executed in that safe. So this is what you can do during this hackathon, have this setup, or maybe you would like to have, multiple agents with one private key each controlling the same safe account. So all of them, or at least the threshold that is defined, need to agree on the decisions they make. But you will also want to have a mixed setup where different, or just one, agents are proposing or suggesting different actions that can be executed in the safe, and you as a human with another private key are the one who ultimately executes those decisions. But today I want to focus on the SDK that we have, the SafeCore SDK, and independently on the setup you have, if you have one private key or multiple one, if you are controlling as a human the private key or an agent is doing that, how to interact with Safe via the SafeCore SDK. On Monday, my colleague Louis will host another workshop on how to set up, and he will cover more details about that, how to run an agent with Safe. But today, let's focus more on the SDK side. So the SafeCore SDK has a couple of libraries, and I would like to give an overview of all of them. And we can showcase them as different layers, so different alternatives you have, and how each of them can help you, what is the one you should go with, depending on what you want to do. So let's start with the basic one that has from one side the protocol kit library. The protocol kit is a TypeScript package. Well, I forgot to say that the SafeCore SDK is a monorepo that is holding all these libraries, or most of them, and later I will show you where to find them. So the protocol kit, one of these libraries, has all the functionality or offers all the functionality that happens on-chain. This means that allows you to interact with your Safe account and, let's say, sign a transaction on-chain in the contract, execute a transaction with the contract, of course, also read the smart contract to see the setup, like who are the owners, what is the threshold, and so on. Also updating the configuration, adding more signers, removing them, adding modules, guards, and so many other things. But basically, to summarize, everything that happens on-chain is like this protocol kit allows you to do it. Then there is the API kit. If you have worked with Safe before, with multiple people, you may know that Safe has different services running for different chains. This API kit is a library that is able to call the API and send requests to get some information. For example, the history of transactions of a Safe, the pending transactions for a Safe, the balance, etc., and so many other things. Also, there are events that you can receive that happen on-chain, and then you can get them via this API. Main thing is that the API kit allows you, once you create a transaction locally, let's say, and you have multiple signers and want to share these transactions with them, you can submit it to the service, let the others to retrieve it, also sign it, because you will need to have multiple signatures in order to execute a transaction, of course, depending on the setup. And finally, you will be able to execute it. But the API kit is the one that allows to share the signatures. We also have the relay kit, which is more related with fees. A couple of months ago, it was very trendy, the ERC 4337. So this relay kit adds compatibility with it. Also supports the Gelato relay, so both options are valid, and basically allows to pay transaction fees from your Safe, not from the signer, because usually it's the signer who executes a transaction, the one who's paying for the transaction fees. But with the relay kit, you can pay the transaction fees from the Safe. And you can do this with a native token. You can do it with an ERC20 token from the Safe, or much better, you can have your transactions sponsored and paid by a third party, like a paymaster, for example. This would be the first layer. Then we have the starter kit. The starter kit is another library that uses and coordinates the protocol kit, the API kit, and the relay kit to offer this functionality with a much better developer experience. I would suggest that this, in theory, would be the best option for you during this hackathon, because it's the one that has better onboarding for you and more like the steps, all of them are simplified, so it's easier to use. But still, if you want to do more complex things, more granular, you can use the protocol kit, the API kit, or the relay kit. On top of that, we have the Safe React hooks, which is very similar to the starter kit. It uses or exposes all the functionality from the starter kit. The difference is that it uses React hooks. So this is the most suitable option for you if you are using an application with React. So we can have these three alternatives: the one with React, the starter kit for scripts, but also for React or anything, and then the third alternative, more granular. Depending if you are using user interface to interact with Safe, or AI agents that manage different scripts, you can choose between React hooks or the starter kit. Once we have these three, we can now see what we have in our repo, because we have different scripts. We can have an overview right now to see how it looks to create this flow to execute transactions. And also we can see the documentation as well. So I will start with the documentation very briefly. if you go to docs.safe.global, this is the cover with a welcome message, an introduction about smart accounts, and our stack, which is divided between SafeCore and SafeWallet, being SafeWallet the official interface, and SafeCore all the infrastructure and tooling. If you click on SafeCore, you will also see an introduction to it, and then 3 groups, like the SafeCore SDK, which is the one we are going to talk about today, the SafeCore API, which are the services like the transaction service, also the Safe Event service, and some others that are running. And of course, the Safe Smart contracts. So let's click on the SafeCore SDK. That is also accessible via this top menu here with the SDK tab. Here on the sidebar, you will see different kits for the SafeCore SDK, the ones we saw before, the starter kit, the protocol kit, the API kit, and the relay kit. Then you will see another section with React hooks that we will see later, and then some other related thing, like related topics, SDK related topics, let's say that way. But we are going to cover the first 2 in this workshop. So here there is an overview for the starter kit, protocol kit, API kit, relay kit, and some resources. For each of these, we have some guides. For example, in the protocol kit, here you can see step by step how to do a safe deployment, how to deploy new safes, how to execute transactions with the protocol kit, and so on. You can do the same for the API kit or the others. And also all of them have references. For example, the protocol kit has a reference with different sections for passkeys, for transactions, to configure the safe, to deploy a new safe. And you can navigate all these options and see, for example, how to, let's say, how to create a transaction for a deployment. Then you will see what is the method, how you want to call it, how do you need to call it, the setup you need to have, how to initialize the protocol kit, and so on. And then you will see the return type and all the parameters and what they mean if the current method has any. So let's also see the SafeCore SDK repository that you can find it here. This one in github.com/safeglobal/SafeCore SDK. It is a mono repo with different packages inside of it, but you don't need to check them only if you want to see how they work internally, but this is not the purpose of the workshop. The main thing, or the most useful thing for you, is this playground, where you will find different folders with the API kit, the config, the API kit, the protocol kit, the relay kit, and the starter kit. And inside of them, and now we can switch to VS Code. Inside this playground, you will see different scripts for these kits. And now we are going to have a look at the code a little bit, step by step. So let's start with how to deploy a safe with a protocol kit. You can find this script here. It has a main function that is executed here at the end. And the first thing you need to do is to create a configuration for your safe, the one you want to deploy. You need to specify an array of owners you want to have, and also the threshold you want to use. The version and the salt nonce are optional values. And then you can import the safe class from the protocol kit library or package, and then call the init method to initialize it. You can pass a provider and a signer. You will see that both of these properties many times in other initializations, and then a predicted safe. This predicted safe is predicted because we don't have a safe that is deployed yet, but it has a safe account configuration, meaning the owner and the threshold, and also a safe deployment configuration, like the salt nonce of the safe version, in case you want to specify a specific one. By default, it will deploy the version 1.3. But if you want to have safes that are compatible, for example, with the ERC4337, and you want to play around with not paying transaction fees, then you should specify here the version 1.4.1. Once you have the protocol kit instance initialized, you can have access to different methods, like to check if the safe is deployed or not, to get the address of the safe that is not yet deployed, and some other things. After that, we can create or we can call the method create safe deployment transaction that will return a deployment transaction object that later you will need to execute with a signer. And then here in this case, we are using VM. So if you have a private key, you need to create an account and then instantiate a VM client. And with it, using the safe transaction method, for example, you can take the transaction we got from the create safe deployment transaction and just execute it. You will get the transaction hash. Using this utility function from VM, you can wait for the transaction receipt, and you will get the transaction receipt. And then using the get safe address from deployment TX from the protocol kit, passing the transaction receipt and the version, you can get the safe address that was deployed. Now, so we had this protocol kit instance, which was initialized with a predicted safe. Now, with the safe address that we deployed, we can call the connect method, pass the safe address, and now we will have the like a fully initialized instance of the protocol kit. This is how you deploy a safe with the protocol kit. Now, if you want to execute a transaction, for example, with this safe or your AI agent, of course, you can go to this different script, the second one we have for today, where we will see how to do it. Again, there is a main function that is called at the end that will execute. Once again, you need to initialize the protocol kit, this safe class. We are getting it from the protocol kit package. We call the init method here. And now, instead of passing a predicted address, we can pass the safe address we got deployed. Now, depending on the transaction we want to execute, we can build an object with a two-value data and the operation that we call the safe transaction data. If we call the create transaction method from the protocol kit instance, safe, we can pass an array of safe transaction data. We can execute one transaction or a batch of them. And we can create the safe transaction object, because now with the signers, we need to sign it. In this case, our safe, it only has one signer, so we can use the instance of the protocol kit that we initialize with our first and only signer. We call the sign transaction, passing the safe transaction, and optionally we can select the type of signature we want to have, but that is optional. And now we get a signed safe transaction. Because we only have one owner, so threshold is 1 and signers, the threshold is 1, we can directly call the execute transaction method with the sign transaction. And now we would get the transaction executed. This is helpful in the case of AI, for example, if you have a script and a setup of a safe that has one private key that is managed by an AI agent. So this setup doesn't need any more signatures. But in the case you have a setup with multiple signers and threshold greater than 1, you would need now to use the API kit. So we can close these two scripts. Now go to the API kit and you will see that there are 3 scripts. So once we have the safe deployed, we need to create a transaction, propose it to the service, then another signer or the others signers would need to get the transaction from the service, sign it, submit the signature, and then somebody needs to execute it. So if we check the proposed transaction, how do we do this? How do we do this? There is a main, again, method that is a function that is executed at the end. Inside of it, now we need, of course, an instance of the protocol kit with the current safe that we have, and also an instance of the API kit that will allow us to interact with the safe transaction service. When we have our transaction created, here, the safe transaction with the protocol kit, as we saw before, at some point, we will need to use the API kit and call the proposed transaction to send it to the service. And here we need to specify a couple of parameters, like the safe address, the safe transaction data, the safe transaction hash, the sender address, the one who is sending it, and also a signature from it. And we can get this data by using the protocol kit to get the transaction hash of the object we created, and then using the sign hash method to sign it and get the signature. So now we have the transaction proposed to the service, and we have other signers that also want to sign it. So how do they get it? Well, notice the confirmation step. So if we are running this script from a different place, again, we need to initialize the protocol kit, but this time here in the signer, we would use a different one. Also have an instance of the API kit, and there is a method. Oh, well, we need to get the transaction from the service, right? So if we have the safe transaction hash, we can call the method getTransaction and get it. There are also other methods you can check in the reference, like get pending transactions or some other ways to filter them. So once we have the safe transaction locally in the second signer, we can get the safe transaction hash, sign it with the protocol kit again, and then call the API kit.confirm transaction with the safe transaction hash and the signature. This way, we are submitting the signature of the second signer to the service. And now we have 2 signatures. And now let's say that the threshold is met because it was a 2 out of 3 safe. Now we can use the execute transaction script, or you can get anything you need from here, where basically we are initializing the protocol kit and the API kit again. Now it doesn't matter the signer you use, because any of them can execute it. You need to get the transaction again, or if you already have it because you did something before. Anyway, you need the safe transaction object. And using the protocol kit, you can call the execute transaction method, get the transaction response. You can wait for the receipt, and the transaction is executed with multiple signatures that happen off-chain. This was with the protocol kit and the API kit. Now let's say you don't want to pay the transaction fees from the signer who is executing the transaction, but you want to get them sponsored. Now is where the relay kit comes into action as an alternative. So here in this script, we will see how to deploy and execute, like deploy a safe and also execute a safe transaction via a user operation using the infrastructure from Pimlico. So before running this script, you will need a Pimlico API key that you can get from their dashboard, and that at dashboard.pimlico.io. And here we are using the Safe 4337 pack that we are importing from the relay kit. With it, we can pass a few properties of the init method, like the provider, signer, the bundler URL from Pimlico, some paymaster options depending on whether you want to pay the transaction fees from your safe, in the native token, in a ERC20 token, or if you want to get the transaction sponsored. In this case, we are getting it sponsored, so we can specify the is a sponsored Boolean property and set it to true. If there are any policy IDs from Pimlico, you can use them and then specify the paymaster URL. Regarding these policy IDs, you can read more on the Pimlico documentation and dashboard. And apart from the transaction fees or paymaster options, we need to specify some safe options. If we don't have a safe and you want to deploy a new one, again, it's the same. The properties don't change. You need to provide an array of owners, the threshold, and optionally salt nodes. Later, you will see that if you have already a safe that is compatible with ERC 4337, so it's version 1.4.1, you can replace these options with the safe address. So it would not be a predicted safe, but actually a safe address. Once the safe 4337 pack is initialized, you have access to a collection of methods. You can check if the safe is deployed or not. You can see what are the entry points from the ERC 4337 that are supported. You can see what is the current signer, etc. And now we want to execute a transaction. So in this case, well, you may want to fund the safe. This is just for this testing script because, well, the safe is non-existent right now, so you can fund it. And now you can build. Here we are building an array of transactions, sending some USDC out of the safe. And with the safe 4337 pack, you can call the create transaction method, pass the array of transactions, and you will get the safe operation object. With it, you will need to sign it with the signer that you have connected to the safe 4337 pack instance, call the sign safe operation, pass the safe operation, and you will get it signed. And finally, you can call the execute transaction method, pass the sign safe operation, and the safe operation will be executed. If you have the same use case than here, where the safe is not deployed, this execute transaction will do a batch where your safe is deployed and also the transaction you want to execute, in this case, a batch of 2 USDC transfers, will also be executed. So the execution is, the deployment is counterfactual, meaning that it's not deployed at the beginning, but when the first transaction is executed. Cool. So now we have covered the protocol kit, the API kit, and the relay kit. Of course, for the relay kit, there are other options and other scripts you may check depending on your use case. This is just one basic example. We don't have time to cover all of them, but feel free to do it on your own. Also, we have, you can check the documentation here and go to the API kit, to the guides, and see how to do it. This was the alternative number 3, the one that is where you control all the different steps and you have access to very granular configuration. If you want to do this in a simpler way, the starter kit is recommended. It should be the way to go. And now we will see how it simplifies all of this, but it's also nice that you know what is happening behind. So here in the still in the playground, in the SDK starter kit folder, there are several scripts as well. We are showing now the send transactions. So how is this flow happening with the starter kit? All the like the proposal of a transaction, getting it from the service, submitting the signature, and finally executing it. Here, everything is summarized primarily to two methods: the confirm method, the send method, and the confirm method. Depending on the configuration of your safe, you would need just one or both of them. How do they work? If you have a safe that only has one private key, one owner, the send method is enough for you to execute one transaction. You call the send method, and transactions will be executed directly. If there are more signers and you need to share the transaction with them and collect all the signatures, then the confirm method will be needed as well. The behavior of each of them will vary depending on this configuration. For example, for a safe that is 1 out of 1, so only one private key, the send will execute. However, when calling the send method, if it detects that the safe has multiple owners, instead of executing, it will propose the transaction to the service. So it's available for the other signers. Now, when the other signers need to sign, and this is why this confirm method function is only called when threshold is greater than 1 or greater than 2. It's because the confirm method will get the transaction from the service, sign it, and submit it again. And also, if it detects that the threshold was met, so the signers have collected the signatures that are enough to execute the transaction, the confirm method will also execute the transaction. So you just need these two methods, and everything that happens inside of them is transparently for the developer and much easier to use. So let's see how this works. Here, we, of course, need an instance of the safe client with the create safe client. We get it from the SDK starter kit package. Again, the properties are very similar as the ones we saw before. We need a provider, a signer, which will be our first signer, and then some options to deploy a new safe, an array of owners, the threshold, and an optional salt nodes. Once we have the safe client, we have access again to several methods to get if the safe is deployed or not, etc. We can create a transaction like this one or an array of transactions, and then call safeclient.send. This now here it will happen what we explained before. It will execute directly, or if there are multiple signers, submit it to the service. So now we need to take into account when do we call the confirm method, if it's needed or not. If it is, we need to, again, initialize the create safe client, but this time with a different signer, the second one or the third one, or the ones that are needed. And at some point, we will need to call safeclient.confirm, and we need to pass the safe transaction hash that we can get from safe client get pending transactions. If there are many, because this will return all the pending transactions, you can iterate on them or look for a specific transaction hash you are interested in, and then call the confirm method for that one or for all of them to submit the signatures. And then if the transaction is ready to be executed, it will do that automatically. So that's how it works. It's much simpler for you. Just 2 or 3 methods: the send, the confirm, and the get pending transactions. And also the Safe Starter Kit is modular, meaning that it works with, or it is compatible with 4.37 and other things, because when you initialize the safe client with the create safe client function, you can add or you can extend its functionality by adding different extensions. In this case, you would like to add one that adds the functionality to make it compatible with the 467. In this case, safe operations, that we also get them from the SDK starter kit. You will need here to provide the bundler URL, if you want the transactions to be sponsored or not, and then the paymaster URL. And now, instead of using the send and confirm methods, you would need to use the send safe operation, or here, the confirm safe operation. All the logic, the rest of the logic is the same. It's just that you have available send and confirm method, and also send send safe operation and confirm safe operation if you want to use the 467 features. So now if we go back to the documentation, here, now we see that we covered the protocol kit, API kit, relay kit, the starter kit as well, which I will again repeat that this is probably the best way to go for you. But also we have the React hooks here, that and this should be the way to go if you are using and interacting with Safe from a React application. It's built on top of the starter kit, so you will see a lot of similarities with these send and confirm functions. We have a quick guide here on how to use it, but basically you can do some imports, prepare your signer, and then at some point you need to initialize them. If you have worked previously with React hooks, you will need a safe provider that wraps your application. In this case, it receives a configuration. I guess at this point now this configuration sounds familiar because it is the same as the one from the starter kit. So you can specify here a safe you want to deploy, or the address of an existing safe. Here you have the option as well. And once the application is wrapped with this safe provider, we will have access to different React hooks to execute transactions. If you want to, well, you will need to start with the send transaction. So the use send transaction hook is needed. That will return the send transaction function. You can call it from, let's say, the onClick event of a button, and then pass the send transaction parameters. This will execute the transaction or submit it to the transaction service, depending on the safe configuration. And if you need to confirm this transaction with other owners, here there is the use confirm transaction hook as well that will return the confirm transaction function. And here there are other hooks. There are more you can check in the reference, but these are the main ones. Use safe. With this, you can get the get pending transactions function. If you call it, it will return some data that are all the pending transactions that the current signer needs to sign. You can iterate on them, print them if you need it, and then maybe you can have a button for each of them that calls the confirm transaction function, passing the transaction safe TX hash. This way, you will be able to add the signature for each of them. So basically, these are the different libraries or SDKs we have available for you during this hackathon and also after, of course. The GitHub repo for the Safe React hooks, you can find it here in github.com/safeglobal/ safe React hooks. This is independent of the safe core SDK monorepo, but both of them are available for you. So yeah, you need to decide which of these alternatives fits better your use case. And then these are the resources, as we saw, available for you. We also have a Twitter account or X account @safe, our documentation, docs.safe.global, our GitHub, safe global. Also, if you have any questions during this hackathon, feel free to share them in the Telegram group or also in Extract Exchange using the tags safe or safecore that the team is checking constantly. And now, thank you very much for watching this workshop, and I hope it was useful for you. Now, we will have some time to reply to your answers if you have any. So we are available here for you.
Yeah, I addressed a couple of doubts and questions in the chat. We have a new one. Which of the kits do you recommend for the React? I mean, if your app is a React app, I will strongly recommend the Safe React hooks, of course. And if not, I think that the starting point will be the starter kit. Is the best option, I think. And after that, if you need to perform a very complex operation with a safe, you can switch to the protocol kit. But I would recommend you to use the starter kit. And if your application is a React app, I think that the React hooks should be the best option.
Maybe we can wait a little bit more to see if there are any other questions. Otherwise, you can send them asynchronously via the Telegram group or Stack Exchange as well. So I guess that's it. Thank you very much again for attending this workshop. On Monday, after the weekend, there will be more from Safe on how to set up an AI agent with Safe, and also many other workshops from the different sponsors of the hackathon. Still, if you are not registered yet, you are still in time. Yeah, and then good luck to everyone and have a fair hackathon and competition. Good luck. Bye-bye.
Good luck. Bye-bye.